Hello, my name is Mohammad Zishan Yusuf, and I'm recording this video as part of my data science project for the deep learning module. So I am doing the sentimental analysis on audio data. So I'll explain step by step what I am doing in this project. So first of all, I am mounting my drive here. So the purpose for this is because my dataset is very long, so I have to upload my dataset in my drive and to get it access, because if I try to access it from my local disk, so it is taking very long time. So that's why I have put my data set in my Google Drive, and I'm accessing my data from there. So first of all, I'll try to mount my drive. As you can see, so I have mounted my drive. So the first step is here you can see is I'll try to get my data load in the Google Colab. So here I've given the path to my dataset. Here, as you can see, in my drive here, this TSS, this is my data. So these are all the different classes that we are gonna cover in this project. So here you can see this is the loop that I have implemented to get in all the folders and get all the information of each file from each folder. So as you can see, so it will give us a basic information regarding the audio files that we have in each folder. As you can see that we are having the shape of the data, the sample rate, which is pretty much same for everyone, and the duration. So the second step is about the pre-processing. So as you can see this in this step, I have tried to get the information of each data file. Like here you can see I have mentioned like the file name, the emotion, the speaker ID, and the folder. So since my data set is very large, so I'm also only focusing on the female data set, in which we have two categories, like the older one and the young one. So here you can see that from each folder we are getting the information for each file. So as you can see, this is the file name and the emotion and the speaker ID and the folder from which we are getting the files. So as we're getting all the information, we try to upload in and try to make a database from which we can use further in our pre-processing techniques. And here we can see I have tried to upload all the 2800 files, since the dataset was very long and we are only focusing on a certain part, that is the female voice, and only two part of them, the younger one and the older one. So the files that we are working here are 2500. So here I have created a database in which I've loaded all my 2800 files, and here we can see that I have so in this step I have extracted only the emotion on which we are gonna work. So this is something that I have narrowed down in my project. So for the time being, I have um, neglected the like we could say the the voice of the woman, like if it's the older one or the younger one. For the time being, I'm only focusing on the emotion. So here you can see that I have extracted all the emotions, and here as you can see, so these are the emotions that we are gonna tackle in this project. So the total they are uh, these are the emotions that we have extracted out of 2800 files, and we have tried to create a CSV. Also, similarly, I have saved my CSV in my drive, so that we can easily access our CSV from there. I don't want to save anything on my local machine. So here I have simply plotted the emotion count that we have for each class. So as you can see that the four of them are have a higher count than the rest of them. It's because as I've told earlier, because I am neglecting the kind of voice, like the older one or the younger one. So if we merge all the emotions that we have from all the 28 files, so these four have the higher number than the rest of them, but out of total 2800. Okay, so this is the sample that we are trying to get the sample rate and the shape of our data. So for here we are trying to get the shape. And as you can see, first of all, I tried to load the data, and here we are doing some pre-processing techniques in which we are getting the spectrogram of our the voice, in which we are getting the patterns and the heat map for the patterns, trying to check how we can s- how we can see the patterns in the voice. Also, it's the same one trying to get the pattern so that we can extract some data out of it. So this is the data augmentation technique. Basically, this is the data more of the convolutional techniques in which we try to introduce different kinds of voices for the same voice by applying different techniques, like we're adding noise, we are shifting the frequency, we are stretching the noise so that when we enter any random file for the testing, so our system should know that there are multiple types of sound from the same kind of voice. So these are the steps that I have implemented in this one. Like this is the normal one, as you can see in this graph. And here you can see, like in this one, we have added the noise, and here we have stretched the audio. And in this one, I have shifted the frequency of our audio file. And here I have changed the pitch. I have also changed the frequency here in this one. So these are the data extraction techniques that we're gonna apply on our project. And as you can see that I have applied this one, and we are gonna do the also do some padding too and some root mean square, and we are gonna extract all of these information out of those audio files. And like these are all the data processing techniques that we have used, and try to create a CSV file and save that CSV file with some numbers in our drive. So here we can see I have processed that CSV file and try to calculate the total time for that the file so that we know that how much duration do we have for the whole, and try to get to know that how much time we're gonna need to load our uh, deep learning module, also to get to know that how, like if our data is suitable, if it's short or if it's larger one. So in our case it's 341 seconds. Also, as you can see, like we have just generated we have implemented a loop in which we are trying to get the start time, and we're going to estimate time whole for the whole data set. So yeah, I've loaded my CSV file from my drive. So here, as you can see, like there are some missing files, which are not processed clearly or what. So what we'll do, we'll apply the basic techniques of filtering out our data to clean it. So checking the missing files, dropping the missing files. So these are the basic techniques that we are gonna use, and from here we are gonna start preparing our data to implement the deep learning module. So for that, first of all, we are doing the one hot encoding, since we have converted our audio files into some numbers, and with respect to all those numbers there are some emotions. So we are changing the emotions with the one hot encoding and giving them some sort of number, like 0 for sad, 1 for happy, 2 for fear, like this one. And we are just printing out the shape. Here we can see I'm splitting my data into 80/20. Like I'm using the 80% for the training and 20% for the test. Here I have implemented LSTM. This is a model implementation, as you can check. So these are the techniques. I have also implemented two techniques. Those are early stopping, and the first one is the early stopping, and the other one is the Yep. And the other one is the epoch. Why we are using these techniques? So the purpose of using these two techniques is when we start training our model, we have to manually give the epoch number each time to check if it's the accuracy is increasing or not. So by putting these two functions, the model is adjusting the epoches itself, and it will stop the training when it feel that it have the confidence that it has done the enough training and the model has already reached its maximum learning. So as you can see that these are the learning rate and optimizers that we are using in our case, and yeah, and this is the basic training that we are good, and we have shifted some other techniques, and we are using some different techniques, and also uses the CNN, and this is the model for the CNN that I have loaded and have put the different the parameters to load our deep learning module for it to learn. So these are the techniques. So as you can see, after the learning, if I could show here the accuracy of my model for the time being after using the CNN model, it is 75%. So this was the accuracy of a model, and the validation loss is 70%. Also, I have saved this model in my Google Drive. So, and I also saved the optimizers and epoch in case if I load the same model again, it's not gonna corrupt. So here, as you can see, I have saved my model uh, in like this one. Yeah. So I have saved my model, the CNN model, and my epoches and my optimizer so that my file do not corrupt. And the rest one is I have try to make the better the epoches and one, but it's almost still the same. And I save the model again, and I have loaded. This is about the prediction. What I've done, I simply give the path file to from the data set I have already loaded in my drive to try to check to predict the outcome of my model. As you can see, then I have it's getting the emotion surprised. So I have saved my model, and I also try to check that if it's not corrupting. So yeah, the rest of the part is about the prediction, about the reloading, and try to predict again that if it's working properly. And about the second one about my interface. So here I am using the Streamlit as there's no restriction of using any of the libraries, so I'm using the Streamlit. And here I have simply load my model here and integrate the Streamlit library, trying to giving the basic preprocessing function that if we try to upload our data and if we try to upload our data, so it perform the basic preprocessing, making it suitable for our model to get to pre-process and then feed it to the model to get the prediction. So here, as you can see, if I could run, yeah. So mm, as you can see, when I try to run my there, it's redirecting to my desktop, and we'll have wait a little bit. So as you can see, this is the basic the UI of my project. So here I have already downloaded the the test file. This is not from this is not from the this is not from the folder. the data that I've already uploaded on my drive, it's something that I have downloaded entirely different from the web. Try to check if my model is predicting. So as you can see, I have browsed my file there. It's running and gonna, yeah, it's giving me the prediction that it is weird. So that's all for my project. So thank you.